All right, this is your Module 3 assessment review, so I'm going to go over the answers for these. So, use the table to complete problem 1. So, is this relationship in the table proportional? Why or why not? So remember, in order to be a proportional relationship, it has to go through 0, 0 and have a constant rate of change. So this one looks tricky, guys, but you got to be careful. Just because it's not going in a nice orderly fashion from left to right does not mean that it's not proportional. So we need to check every y value divided by its x value to check for proportionality. So we need to identify if a k exists. So try to find a k. Now if you're getting different numbers, then it's not going to be proportional. So let's take this first point. So 6 to 70. And I guess we need to say which one is x and which one is y. So does it make more sense to have miles per hour or hours per mile? And obviously miles per hour is going to make more sense unless you're running the mile like you guys did in gym class. But that's not what we're doing here. So our time in hours is our x and our distance in miles is y. So we want to take every point and take the y value divided by its x value. So for the point 6 to 70, we're going to take 270 divided by 6. And you can use a calculator to figure this out. So when you punch that in, you should get 45. Now we need to do the second point. So 229 and a half, which is the y value, divided by its x value, which is 4 and a half. So when you plug that into the calculator, you get 51. So already we have seen that these two values are not equal. So there is no k that exists because it's not constant. So that means the relationship shown between hours and distance in miles is not proportional. So no, not proportional. And our reason is because the rate of change is not constant. And you can also say variable. So it's not constant. So there is no k value. So remember, you have to check the points. And even if the first two worked, if they both had the same rate of change, you can't just say that it's proportional. You have to check every single point that you are given. So be careful on that to make sure that it is or is not a proportional relationship. Also, make sure on the test when it asks you to explain or say why or why not, make sure you're using your words and explaining your reasoning. All right, moving on. So we've got a graph. The graph showing the amount of vinegar and water in Martin's cleaning spray is shown at right. Explain why this situation is a proportional relationship. So I'm telling you that it is a proportional relationship right here. And you're supposed to say why. If you remember from class or from your study buddy, if you've watched that video or filled it out yourself, we know that if we're given a graph and we're trying to determine if it's a proportional relationship, we look for two things. First thing, is it going up at a constant rate of change? Is that a straight line? And it is. So our first reason is because it is a straight line. And we can say that that means it has a constant rate of change. And then our other reasoning that it is proportional, it can't just have a constant rate of change, it can't just be straight, but it also must pass through 0, 0. So we can see clearly on this graph, it passes through 0, 0. So, and it passes through 0, 0. Both of those have to be true in order for it to be a proportional relationship. Another way you could do it is actually take each of those points that you see except for 0, 0, but the other points that you see and do y divided by x like we did in number 1 and show that it is the same. So this point is 1, 5, so 5 divided by 1 is 5. And then this point is 2, 10, so the y value 10 divided by 2 is 5. 15 divided by 3 is 5, 20 divided by 4 is 5, and 25 divided by 5 is 5. So we can see that it has a constant of proportionality. For number 3, we're still looking at that table and just going to go over what I just said. We want to complete the table to display the data shown on the graph. So we're going to pull those points off the table. I only have 5 spots open. So if you want to put 6, that's okay because I didn't include 0, 0. So I'll go ahead and do that here. So 0, 0 is on our graph. And then we can see this point right here is 1, 5 because you go to the left one, up 5. The x value goes first. And vinegar is our x value because it's on the x-axis, and water is our y value because it's on the y-axis. And then you have your next point here, which is going over 2 and up 10, so 2, 10. Our next point, over 3, up 15. And then 4, 20. And then our last point is 5, 25. Right here, 5, 25. So remember, our scales aren't the same. This one is actually going up by halves. This is a half, a half, a half. And then our y-axis is actually going up by 2.5 because this is 5. So half of that would be 2.5. So be careful when you're reading your scales as well. So that's the table to show the data in the graph. Number 4, we're still talking about that one. So what is the constant of proportionality K in the graph of Martin's cleaning spray? So what's nice about this is since we already know that it's a proportional relationship, we don't have to do well, we wouldn't do 0, 0 anyway, but we don't have to do every single point. We only need one of them because we know that it's constant. We know it's going to be the same thing because the graph is straight and goes through 0, 0. So pick any point you want. I think the easiest one is the one that has a denominator of 1 here. So y over x, or our k value, is going to be equal to 5 over 1. So k is equal to 5. And then for number 5, write the equation in the form y equals kx. Remember, that's the equation for a proportional relationship. It's just your y value is equal to some value k times your x. To get from your x to your y, all you do is multiply by your constant of variation. You don't add something or subtract something after it. It's just strictly multiplying by something. So what is that something? We just found it in number 4. That's your k value. So when you're writing y equals kx, I know that for this specific situation, my k value is equal to 5. So my equation is y equals 5x. So that means for every 1 cup of vinegar, there are 5 cups of water. So the ratio of vinegar to water for this cleaning spray is 1 to 5. So that's my equation. So if you want to have 7 cups of vinegar, say we wanted to find out for 7 cups of vinegar, which is not on our graph, since 7 cups of vinegar is our x value, we know that that would go in for the x. So we can say, okay, the number of cups of water, y, is equal to 5 times that number of cups of vinegar, which we said was 7, so you would need 35 cups of water. So you can use this equation to get you more values that weren't on your table or weren't in your graph. Okay, moving on, we've got a new table here. So it says use the table that represents a proportional relationship, so that's really important. Anytime you see that, I would just highlight it, underline it, make sure you remember that that tells us something. So the relationship is proportional, and use it for problems 6 through 8. So for number 6, it says this table represents a proportional relationship. Again, proportional relationship. And that tells us that it goes through 0, 0. It has a constant of variation k. What is the constant of proportionality? So again, just like our last one, since we know it is a proportional relationship, that means every single y divided by x is going to be equal. So I don't need every single one of these. It doesn't matter that I have a bunch of blanks because I know I can just take one of them, divide the y by the x, and that will tell me my k value. So be careful here because this table is not like a normal table you would see. The y value is actually the distance driven because we would want to know miles per gallon, not gallons per mile. So MPG, miles per gallon, is the fuel economy for a car, how many miles you can get out of 1 gallon of gas. And the more miles you can get, the better, the less you're going to be paying for gas and the better gas mileage you have. So in this case, and a lot of times it won't be this way, okay? But the y is the distance driven. And I want you guys to get out of the habit of doing the bigger number divided by the smaller number. So in this case, we are going to do 100 divided by 5 instead of 5 divided by 100. But if these were switched, if this miles were the x value and gallons were the y value, you would be doing 5 divided by 100. So don't always assume that the number, it's going to be the bigger number divided by the smaller number. So in this case, it is that way. So the y value 100 divided by the x value of 5. So for 100 miles, 5 gallons were used. And so we can find miles per gallon. We can find that k value, which is 20. So this car gets 20 miles per gallon. So k equal to 20, that is your constant of proportionality. Number 7, write an equation in the form y equals kx for this proportional relationship. Same as before, y equals kx. I know for this specific k, or for this specific situation, my k value is 20. So all I have to do is plug in 20 there. So y equals 20x. So this is telling me if you want to find out how many miles you can drive, you're going to take the miles per gallon times your number of gallons, and that will tell you how far you can go. So if you say you have, it goes up to 30 here, but say we have 40 gallons of gas. So that's our x value. So we would say, okay, to find the y value, the distance in miles that you can drive, you get 20 miles per gallon. So 40 gallons. So for each of those 40 gallons, you get 20 miles. And when you multiply that, you get y equals 800. So you would get 800 miles for 40 gallons if your car goes 20 miles per gallon. Okay, and number 8 is fill out the rest of the table. So we're just going to use our constant of proportionality to help us out here. So just like I used the equation, okay, we don't actually have to plug it into the equation, but we can do the same thing. So to get from 100 to 5, we divided by 20. So for 200, we're going to divide by 20 to get how many gallons we had to go 200 miles, and so that would be 10. And you can check to make sure 10 times 20 is 200. Okay, now they tell me number of gallons, so just like I did down here saying that I had 40 gallons, 15 gallons, I would multiply that by 20 to see how many miles I can drive. So 15 times 20 is 300. And then I go back to knowing the miles driven, so I want to divide by 20. So 400 divided by 20 is 20. And then I have a space here. So really you could put anything, but it follows that we're going up by hundreds. So this next one we would want to be 500. And divide that by 20 and we get 25. So since this is a proportional relationship and this one's going up by the same thing every time, this one will too. So we can see we're just going up by 5s there. But that will only happen if, your top is also going up by a constant rate for the points that you see. Because I don't have to include all these points. I could have skipped this one. I could have skipped that. However, for 300, it would still be 15 gallons. All right, now we'll go to the back side. Okay, for problems 9 and 10, find the rate of change. So in 2017, quarter one sales for iPhones were 78.2 million units sold, and during quarter three, Apple reported 41 million units sold. So they went down. We can see already that they're not selling as many iPhones, and that's probably because of the release of the iPhone, I think it was 7, earlier this year. So to find rate and change, remember, if you look at your study buddy, for rate of change, we need to look at 2 points. So what are our 2 points here? Well, we know for quarter 1, there were 78.2 million units sold. So we can just know that this is in millions. And then for quarter 3, there were 41 million units sold. So what we're doing is we're treating the quarters, the time, as the X value and the number of units sold as the Y value, because it depends, the amount of iPhones sold depends what time of the year it was. So another way we can do this is using a table. So we can put in a table quarter versus units sold. This will make a little more sense, I think. And just make sure you put in millions. It's important that we know that these numbers are in millions and we didn't just sell, or Apple didn't just sell 78 phones and 41 phones, rather 78 and 41 million. So for quarter 1, 78.2 million iPhones sold, and then for quarter 3, there was 41 million sold. So then here we can just use our how do you get from one to the other, or you can actually subtract. So I'll do it both ways. So for the change in Y, remember Y is going to be our units sold. So that's the number of iPhones, and the quarter is the X value. So we're going to do change in Y over change in X. So for change in Y, how do I get from 78.2 to 41? Well, I'm going to decrease. Well, by how much? So you can just subtract that. So you can say 78.2 minus 41. Okay, and you can use a calculator, it's fine too, but that's going to be 37.2. And that's going to be a negative value though, because I lost that many. My sales went down. And then how much time's transpired? And so that would be my quarter, my change in X. And so how do I get from 1 to 3? Was adding 2. So 2 quarters had gone by. So then that's your rate of change. So you can just divide that number to find the rate of change. So negative 37.2 divided by 2, and that will give you negative 18.6. So that's your rate of change. And again, we can just do subtraction. You can use the formula. So we would take quarter 3's Y value, 41, minus quarter 1's units sold, and then we know that 41 happened in quarter 3, so we're going to take 3 minus 1 to figure out how much time has passed, so 2 quarters, and again went down by 37.2 million units. And so this label here is negative 18.6 units per quarter. So they decreased in sales by 18.6 million units per quarter in 2017. So just make sure that you know which one plays the role of X, which one plays the role of Y, and that you're doing Y divided by X. And again, making a table is really helpful here. Okay, this next one we're talking about a basketball team. So they had 25 points after 16 minutes of play, and then after 24 minutes of play, which would be a third quarter, for 8-minute quarters, they had 49 points. What is the rate of change from 16 minutes to 24 minutes? And again, we want to include labels here. So I'll just make a table again. So we're going to say how many minutes, and then points. So after 16 minutes, 25 points, and after 24 minutes, they had 49 points. So we know that minutes is the X value because we would want to know, what we're going to find out is how many points are scored per minute, not how many minute per points, because that would be a small number and really wouldn't make sense. We want to know how many points they can or have scored per minute on average in the game. So again, making that table really helps. So how do I get from So this is x, this is y. So how do I get from 25 to 49? That's my change in y. So my change in y is they increased by 24 points. Well, how long did it take them to make those 24 points? That's important. So how do I get from 16 to 24? And that's by adding 8. So they increased by 24 points after 8 minutes of play. So then we can divide that to find points per minute. So that would be 3 points per minute. So our rate of change is positive 3. And if we put our label in there, that means that the basketball team scored on average 3 points per minute. All right, next one. So Miss Booten loves Jelly Belly jelly beans, and I do. My favorite is toasted marshmallow. So a 16-ounce bag of jelly beans costs $9.44. What is the unit rate for this proportional relationship? Again, proportional relationship, so we're just going to highlight that. So that means a k exists, so we know to find k, we do y divided by x. So we're going to find the unit rate by finding our k, because they're the same thing. K is the unit rate. It's also the slope. So which one of these is x and which one of these is y? Well, does it make sense to know how many dollars per ounce or how many ounces per dollar? And it's how many dollars per ounce. How many dollars per ounce? So we're going to take the amount of money it costs, $9.44, and we're going to divide that by the number of ounces I get for that price. So this is a unit rate, so we want this to be equal to 1 unit, so that's 1. So we need to divide both the numerator and denominator by the same number to get an equivalent fraction. And we're going to divide by 16 because we want the denominator to be equal to 1, and the denominator is 16. So 16 divided by 16 will give us 1 ounce, so we can figure out how much 1 ounce is by doing $9.44 divided by 16. So $9.44 divided by 16 is 59 cents. So put 59 cents. So the unit rate, you can write like that or say 59 cents per ounce. And that's the unit rate. Jelly Bellies are pretty expensive. Okay, moving on. A bullet train travels at a constant speed from Tokyo to Kyoto in Japan. It takes the train about 2.2 hours to travel 319 miles. Predict how far the bullet train can travel in 4 hours. Okay, so this is a little different. This is an application problem. We are talking about the speed of a train. Okay, so we know if that train doesn't go anywhere at all, that's going to be so 0 times 0 hours. So this is a proportional relationship. So let's just go ahead and make a table because that's easiest. So we want to have time in hours, and then we want to have distance in miles. So we're going to find, we have the rate in miles per hour, or we want to find the rate in miles per hour. So y, our distance is our y value, and our time in hours is our x value. So I know that after 2.2 hours, the train can travel 319 miles. So I can use this to find out the constant of proportionality k. I can figure out how fast this train is going by taking miles divided by hours. You guys have many times probably figured out a miles per hour calculation. So 319 miles divided by 2.2 hours, we can get the unit rate, or the k, and figure out how fast this train is going per 1 hour. So you can just divide that number. So just do on your calculator 319 divided by 2.2. So when you punch that into your calculator, you should get 145. So 145 miles per hour is how fast this bullet train travels. So I know if I'm told how long it's going to travel, if I'm told the x value, I would multiply that by 145 to get to my y value to see how many miles that it will travel. So we can actually write an equation here since we know it's a proportional relationship in the form y equals kx, and this 145, that's your k value. So y equals 145x. So now if I'm trying to predict how far the bullet train can travel, so how far, so that's miles, in 4 hours, that's our time, so that's our x value, then I can just plug it into this equation. Or you can put it in the table. So what if a 4 was there? So how would I figure out if I'm traveling 4 hours, how many miles that would be? Well, since it's a proportional relationship, you're going to do the same thing. So I took 2.2 times it by 145 to get the number of miles. So I'm going to do the same thing for 4 hours to get how many miles that is. And that's the same thing as just plugging it into this equation. So I'll do both. So we can say y equals, okay, to find the number of miles y, you're going to take 145, that's speed, times the number of hours you're going to travel, which is 4. Because for every one of those hours, you travel 145 miles. So 145 miles per hour, and there are 4 hours. So 4 times 145 is 580. And again, if you look at it in the table, just like you did 2.2 to get to 319, you would times by 145. Do that with 4 as well, and you get the same answer, 580. So your answer is 580 miles. So when you're asked to predict something, you got to find the relationship between your two variables first, and then use it to find your answer when you're given one more piece of information. All right, last part here is finding slope. So these are graphs. The first 3 are graphs, so we can use rise over run to help us here. So pick 2 nice points on the graph. Remember, a nice point is where it crosses at a grid. So like if you draw a vertical line here and here, we can see that they cross nicely right here. But that point is not on this line over here. So we're not going to use that point because it's not on the line. So you have to find a nice point that's actually on the line, like right here. And through 0, 0. So that's always a nice one to pick if it goes through 0, 0. Okay, so now we just need to start with one point and go to the other point. So I'm going to draw a triangle from here, and we're going to see how far we need to go up or down, and then left or right. So to get from this point to this point, only going straight up and down and left and right, I'm going to go up first since the change in y is always on top. So I have to go up 4 units. So plus 4. That's my change in y. Now I need to finish drawing my triangle there, so I'm going to stay at that point and see how far left or right I have to go to get to that point. And I had to increase by 3. So plus 3. I say increase because I'm going to the right. So that's adding 3 for your change in x. So your slope is 4 over 3. And we can just leave it like that. You don't need to convert it into a mixed number. When you get to algebra, you'll really want to leave it as an improper fraction always. Another way you can do this problem is to actually pull off the points from the graph. So if you look at the coordinate point here, that would be -3, -4. That's the actual coordinate points of that. So I said 3, -4. And then the second point is 0, 0. And then you can either use the formula or you can just draw our arrows here. So how do you get from one y value to the next? So from this y value to this y value, you would add 4, so that's the same thing there. And then how would you get from this x value to this x value? Would be your change in x. And that would be add 3, so that's the same that we got up there. And always remember that it's change in y over change in x. Okay, number 14, you can see that number 13 is a proportional relationship because it goes through 0, 0. But this one does not, so it's not a proportional relationship. However, it still has a slope. So we've got 2 points that are actually, they tell us what the 2 points are here. We can still do rise over run. So I will do rise over run first. So to get from this point to this point, we'll start with this point. So how do I get there if I can only go straight up and down and left and right? I'll need to go up, and so that'll be a positive value, and then to the right, so that will be a positive value. And now I'll count them, so I had to go 1, 2, 3, 4, so up 4, positive 4, and then how far to the right? 1, 2, 3, 4, 5 units, so positive 5 to the right. So my change in y was equal to positive 4, and then my change in x was equal to a positive 5. So my slope is the division of those two numbers, so 4 over 5. And again, just leave it like that. Don't change it to the decimal, which is 0.8. You don't need to do that. Just leave it as 4 over 5. Again, we can pull off those points and do the exact same thing. So -2, 3, -3, and 3, 1. How do you get from -3 to positive 1? Would be adding 4. And then how would you get from -2 to 3? And that would be adding 5. So then again, 4 divided by 5 is our answer, or 4/5. Number 15, again, not a proportional relationship because it doesn't go through 0, 0. But it's straight, so it has a constant rate of change, so it has a slope. Let's pick 2 nice points here. That looks a good point. And right here. So now let's go rise over run. So I'm going to go from this point to this point. I just always start with the leftmost point. It's the least confusing to do. So draw a triangle. So I'd have to go here for up and down, and then to the right. So for my change in y here, I had to go down 3. So that's going to be a -3. And then I went to the right 3 units, so that's a positive 3. So my change in y was -3, and my change in x was a positive 3. So my slope is the division of those two numbers. -3 divided by positive 3 is a -1. Negative divided by positive is a negative. And so look at these last two. They were going up from left to right. So we read left to right, so we go up from left to right, up from left to right. So they have a positive slope. This one changes. It goes down from left to right. So it makes sense that our slope is negative. Again, I'll do it a second way where we can pull those points off. So this first point here is 0, 3. And our second point is 3, 0. And we say, how for the change in y, how do I get from this y value to this y value? So how do I get from 3 to 0? Well, you'd have to subtract 3. And then how do I get from this x value to this x value? To get from 0 to a positive 3, we'd have to add 3. And again, the slope is the division of those two numbers. So -3 divided by 3 is equal to -1. All right, the last one, you're just given 2 points. We're not given a graph. So we don't get to do rise over run. We get to do the second method I've done in all 3 of those so far. And then I'll also do the formula way. So for just the arrows, we can say, how do you get from 18 to 12? Well, I know I decreased. So my change in y, I lost 6, so that'd be -6. For my change in x, how do I get from 4 to 7? Well, I added 3. I increased by 3. And so that was for my change in x. the slope is change in y divided by change in x. So negative 6 divided by 3 is negative 2. And that's my slope for number 16. We can use the formula. So the formula is m, which is the variable for slope, is equal to y2 minus y1 over x2 minus x1. And remember, these little subscripts, they might seem confusing, but this just means the second y value, the first y value, the second x value, and the first x value. So let's go ahead and I'm going to label those over here. So this is my first x value, so that's called x1, and my first y value, y1, so that's x1, y1. Then my second point, the 7 is the x value, so that's the second x value, x sub 2. And 12 is my second y value, so we call that y sub 2. And then we just plug in. So to find my slope, I'm going to take my second y value, which is 12, minus my first y value, which is 18. And then I'm going to divide by my second x value, which is 7, minus my first x value, which is 4. And then we just calculate that. So 12 minus 18 is negative 6, 7 minus 4 is 3, and then we get the same thing as we did up there, and when we divide it, we still get negative 2 as our slope. That's it for your review. Thanks for watching, and just let me know if you have any questions. Please text or email me over the weekend if you need another explanation, but please study for your test and be ready with questions on Monday, and we're going to review some more in class. So thanks for watching.